Here's a very interesting piecewise function. Question 22. Graph the following piecewise function. Is the function continuous? Prove algebraically. There are all parts in it, right? I'd like you to make a note of this, sketch the graph, answer your question, okay? And then move on with the video to see the solution. The function here is f of x equals to 1 over x minus 1 if x is less than minus 1. Absolute of x minus 2 minus 5 if x is between minus 1 and 7, and square root of x minus 7 plus 1 if x is greater than or equal to 7. Okay, so that's the part, and I've purposely taken 3 different types of functions here in one piece so that I can also explain you how to sketch each, right? So in the test you should expect, maybe a quadratic function more, correct? Which you have been sketching since grade 10. Okay, now let's see each part individually, then we will combine them and put them on a graph paper. Okay, so I hope you've done your own solution before you go through my solution, okay, which may not be the best. So ensure that you've done what you know best, and then what I'm telling you will be an additional information for you, and you can do better. Correct, here it is. So the first piece is when x is less than minus 1. So when x is less than minus 1, then we have 1 over x function here, and it says 1 over x has been transformed 1 unit down, right? So basically the whole function, I'm making slightly bigger like this, right? Okay, so 1 unit down. So actual function would have been, let me sketch the part which the whole function, then I'll border the one which is required for us. So the function as such will be like this, right? So that's 1 over x. But at present, we are interested in x less than minus 1. So at minus 1, what value do we have? So let's write down the value at minus 1 here. At minus 1, we'll calculate. If I put minus 1 here, I have 1 over minus 1, which will give me minus 1. Minus 1 is minus 2. So I get minus 1 minus 2, right? So let us say this is my minus 1, and at minus 1 I have this point, and this is actually a hole, right? So let me make a big hole so that I can show you that, well, this is not included, okay? And my graph will move like this. So this is one piece of the graph, correct? Now let's look into the next piece. So the next piece is between minus 1 and 7. So where minus 1 is included and 7 is excluded. And the type of function is absolute function. So absolute function, how should it look like? So basically absolute function is kind of like this, right? But here we moved it 2 units to right and 5 down. So if I move this function 2 units right and 5 down, I get kind of like this. Is it okay? So this is my function, but we are only interested in a part of it, and the part is between minus 1 and 7. So at minus 1, what is the value? At minus 1, let me write down the value here. Minus 1, if I plug in, I get minus 1 minus 2 as minus 3. Absolute value of minus 3 is plus 3. Plus 3 minus 5 is minus 2. So here I get a point. I'm using square brackets because this point is included, right? So it helps me to figure out whether a point is included or not. Don't take it as a coordinate point for the time being. It's kind of a rough work to help me how to sketch, okay? Now, again, so when I plug in minus 1 here, so my x value is minus 1, right? And the y value is minus 1 minus 2 is minus 3, which becomes 3 after absolute, and 3 minus 5 is minus 2, minus 2. So at minus 1 I have minus 2. So let us say this is my minus 2, okay, at minus 1. So it is starting from here. As you can see, this actually fills in the hole. So at this point, we are continuous. Do you see that? So this piece actually overlaps the first one. Perfect. Now, let's check that point. We already know this vertex, correct? This vertex is at, it moved 2 units to the right. So this vertex is at 2 here and 5 units down. So this is minus 5 for us. So we know the vertex also, correct? So let me put this point here. Perfect. How about 7? 7 is not included, so I'll write 7 like this. And if I put x as 7, I get 7 minus 2 as 5. Absolute value of 5 is 5, and 5 minus 5 is 0. So I get 0 here. So that means at 7, we are at the x-intercept, correct? So the part of absolute function which we should join is kind of like this. Do you see that part? So this is my absolute function which I'll be considering in my graph here. Now let's look into the square root function. Okay. Now square root function, we see it is valid from x greater than equal to 7, right? So, and let's try to sketch this function. So here we say square root function normally will be like this, right? So let me sketch it. So normally it would be like this from origin, but here it is a transform function. We move 7 units to right and 1 up. So let's say this is 7 units right and then 1 up, and so it goes like this. Is it okay? Now, as far as the piecewise function is concerned, we are interested in this part, x greater than equal to 7. At 7, what is the point? Which is included. So I'll write like this. At 7, I have 7 minus 7 as 0. Square root of 0 is 0. 0 plus 1 is 1. So this point for me is 7 here and 1 here, correct? Now, as you can see, at 7, we have a discontinuity. So that is our algebraic solution. I'm not writing it here, but I'm trying to tell you so that you can prove algebraically. So algebraically what we did was, we found our points at these joining points where the pieces join together. And for first and second piece, we found that at minus 1, they join together at the same point. So they overlap. And therefore, the function is continuous at minus 1. How about second and third piece? Here, at 7, we found that the value of absolute function is 7, 0, while that of the square root function is 7, 1. They don't overlap. Do you see at 7? We end at 0, but we start from 1. So there is a jump discontinuity. So algebraically we have shown that at the first piece and the second piece, they join perfectly and they are continuous at that point. But second and third piece don't overlap. And so we have discontinuity, and that discontinuity is a jump discontinuity. Correct? So we have basically proven algebraically how the function will look like and whether it is continuous or not. Now let's try to sketch it on our graph. So let's start from left to right, okay? So as you see from left part, so there is 1. So here we have a horizontal asymptote at minus 1 because of this, correct? So basically our function will be approaching minus 1, correct? That is it. Now, basically it starts from which point? It starts from minus 1, minus 2. So at minus 1 we have point here 2, and this is a hole for us, right? So we will from here, it's a very small space, we'll just make absolute function. That is our absolute function. Do you understand? And we'll make an arrow here. So it is approaching minus 1. Perfect. Now from here we have an absolute function, and the absolute function is, as we can see from values, minus 1, minus 2. So at minus 1 we start from here, so it's continuous. See, the point is joined together. and then we have a vertex at 2, -5. So 2, 1, 2, 3, 4, 5. That is a vertex, correct? And the end point for this was 7, 0. When you plug in 7 here, and that 7 is also included. So 1, 2, 3, 4, 5, 6, 7. So 7, 0, correct? So we'll connect these points, right? So we'll connect this point and say, well, that's my absolute function. And on this side, I'll connect this with this, correct? So I got this absolute function. So this is my absolute function. And now we will do our square root function. We say square root function is starting from 7, 1. So this 7, we have a jump discontinuity. But here, square root function is included. Oh, so it is a solid point. And when 1 will move like this, kind of. Do you see square root function? But let me make absolutely clear, this value is not included. So this value will be a whole. Do you see that? This is not included, right? So, as I've shown here, this one was not included. So from this graph, we can see that the function is continuous here, and we have a jump discontinuity. So we say here jump discontinuity, right? Here pieces join together, right? We say pieces join at the point is -1, -2, correct? This point, correct? So here it is continuous and there's jump discontinuity. In general, our graph is 1, each unit is 1, right? -1. Correct? And these are our critical points. This was 2, right? And this is -5. And this point is 7 for us, correct? Anyway, so I hope you understand how to solve this kind of a problem. Let me repeat. The approach should be that you should look into each piece first separately, like I've seen here, and then put them together, correct? So that way is what happens is, one, you get good marks for communication. Second, you're clear in your mind how the things are moving, and you can see for yourself whether the function is continuous or not, okay? Thank you.